Functions let us define repeatable actions that we might want to reuse many different times. And so we define a function that performs some operation, and then we will call that function later. They're really good for helping us organize our code. They help us test our code because we can test one function at a time to make sure that that function works. And then we can keep adding functions and making our programs more complex and do more stuff. So let's start by defining a function. We do that using the def keyword. So def to define a function. This code is a very basic function. It adds two numbers, takes two inputs to this function, a variable called number1 and a variable called number2. And then it will return the sum of those two numbers. Below that, we call the function. So when we say result equals add 5 and 7, we store the value that gets returned in the variable called result. So we can test this out. Let's make this code. So I'm going to write a new file called myfunctions.py. So def to define a function. What's the name of the function? We give it a name, add. Here in these parentheses, these are the inputs to the function. So in this case, we're just adding two numbers. We'll choose number1 and number2. We end this line with the colon just like our if statements, just like our loops. And when I hit return, we're in this code block. We have our indentation here that shows this is the code that's part of our function. This function will just return number1 plus number2. Notice before I add that 2, Python shows us, well, Visual Studio Code shows us that number 2 is not being used anywhere, so that could be a problem. Once I type that 2 there, it's like, oh yeah, you're actually using that. So that's good. So after I define that function, I can use it. So result equals, I'm going to call the function just with its name, add 5, 7. So that 5 corresponds to number 1 and the 7 corresponds to number 2. Then I'll print the result. So let's run this function and it gives us 12. If I know my math correctly, yes, that function did add those two numbers correctly. So that's good to know. We can call that function again. We can use that function as many times as we want. We could use that function in a loop. So we could print add, and we're nesting these parentheses here. So what numbers do we want to add? Let's add 12 and 9, should give us 21. If Python's math is good, we can do it again. Print add 3 and 4. So we're just wrapping the call of that function in the print statement. Otherwise, Python's just going to throw that value away. Like if I call add 5 and 5, we'll see what happens here. All right, so what's going to happen in our program? Let's run it and see what we get. So 12, we added 5 and 7, store that in the result variable, and we printed result. That was 12. Then we did that all in one line without storing anything in a temporary variable. We just added 12 and 9. We printed that result, gave us 21. Then we added 3 and 4 and printed it, which gave us 7. And this last line, it ran, but we didn't tell Python to do anything with the value that was returned, so it just silently finished. You can just trust me, it did run. So this is just code we're playing around with, so I'm going to delete all that. We can define another function that doesn't return anything. Display underscore message, that's my function name. And the input that we're going to take is just a variable name that we're creating, day of week. You can see based off the color, we're not using it yet. We will use it. We're just going to print a message. Today is plus to concatenate day of week. I'll hit tab to accept that suggestion. So that function does not return anything. All it does is print something, and that's totally fine. Display message Monday. And we can call the function again, display message Tuesday. We could also display message the best day ever. Because our code isn't actually checking to make sure that that is indeed a day of the week. So let's run this code, see if it works. So today is Monday, today is Tuesday, today is the best day ever. It works. So we can, rather than copying a print statement over and over and over again, we can define our function once and call that function, and this will make sure that our code runs the same way all the time. Functions are often much longer. For example, if I select all this code, lazy copy and paste, right click, copy that code, I'll just paste it over my existing code. So all I've got there is the code from that example. So what does this function do? Let me hide my files, clicking that icon. So we're defining a function called evaluate student for graduation, and we're taking some kind of student variable here. Now, if we look at the way that we're accessing this function, accessing the student variable inside the function, I see I've got student, bracket, and then a string here, which makes me think, okay, this is a dictionary. So if their coursework, we've got the double equal for the comparison is complete, and the student's GPA is greater than or equal to 2.0, we will set the value on that dictionary of the graduated key to the value of true. And then we'll print a message using the student's name, saying they've been approved for graduation. If those are not true, if the coursework isn't complete or the GPA isn't greater than 2.0, we'll set graduated to false, and we'll print that they have not completed the requirements. So notice on line 8, we do create a dictionary object there. Student equals, that's where we create that variable. Name, Ricky Bobby. Coursework is complete. GPA is 3.5. Currently graduated is false. If we run this code, the student Ricky Bobby has been approved for graduation. So that's good. So this function here is doing some more complicated checking than was done before, and that works just great. So let's create another function. So we're going to create a classic one, convert.py. Convert.py. And so this code is not good. This is not using any functions that we are defining, but this helps demonstrate why we use functions. So let's copy this code and we'll paste it in here. So what are we doing? We're taking Celsius is 30, then we're printing out the result of doing the conversion from Celsius to Fahrenheit. So we got to convert Celsius to a string to print that out. So that many degrees Celsius and Fahrenheit is, and then we've got this math formula here to convert Celsius to Fahrenheit. And the code works. If I run this code, click play, yeah, that's correct. 30 degrees Celsius and Fahrenheit is 86.0. Perfectly fine. But if we wanted to convert a lot of different numbers, we don't want to be copying and pasting this one formula over and over. Copying and pasting code that's repetitious is a bad idea. Instead, we want to create a function that will do it right once, and then we'll call that code later. So we are going to delete this bad way, and we'll define a function called convert. As an input, we'll accept a variable called Celsius. Put my colon at the end. So in here, I'm going to create F equals, that's the Fahrenheit, Celsius times 9 divided by 5 plus 32. And then we're going to return a string, the string message, formatted correctly. Return str to convert that Celsius to a string that we can print nicely, plus degrees C in F is colon plus strf. Now I can just print the result of calling that, because the function returns a string. The function itself doesn't print anything. It just gives me a string. So I would call convert 30 and convert 20. So if I was calling this function 1,000 different times, but there was a bug in my code, let's say if I was doing the conversion wrong, I would only have to fix that in one place and my code would be fixed everywhere. So let's make sure that this actually works. It does. It's giving me the right values. So functions are good for repetitious work. So see if you can, here's a few challenges. So create your own function. I'm going to create a new file called greet.py. In the first line, define a function named greet. So pause the video, see if you can write this code, but I'll walk through it. Def greet. Start there. The greet function should have a parameter called name. So I'll put name in there. That will be the input to the function. And it tells me the function should return. So I'll return a string with a text. Hello name, but we want to use that name variable. Hello plus name. After the function, create an array of names. So I'll say names equals Alice, Bob, and Eve. Did it? It's good. Loop through the names, and for each name, print the result of calling the greet function. So this is a case where we're looping through a list. So a for loop would be a good candidate here. So I can say for name in names, colon, greet name. So will it work? Let's run it. Whoops, bug in my code. What did I do wrong? Don't worry, it's not a big one. The function is running, but I didn't actually print anything anywhere. I want to print the result there. So I get hello Alice, hello Bob, hello Eve. So go through the challenges here. See if you can create these functions using these as examples of defining a function and returning values and printing things. This will require you to combine some of the concepts that we used previously, loops, comparisons, converting data using the length of function, all of that good stuff. You might have to change things from an integer to a string or a string to an integer. See if you can solve those challenges and write that code.